Okay, to continue with the previous video that we have. So we know that this sequence is, we define this one as, this is an example of the infinite or infinite uh, sequence. Okay, so we have it in. So that means the given sequence is infinite. So you will see that one if there is a dot on the sequence. So therefore that given sequence is. Now let's go to finding the sum of the given series or the arithmetic series. So in finding the sum, this is the formula. So let's define it. So it is, when we say sum talks about an operation addition, and sum is the answer to addition, okay, or the operation addition. So when we get the sum, so let's have an example related to activity number 4, the secret of Carl. So we have it here. When we try to get the sum of the first 100 number, so we have 1 plus 2 plus 3 plus so on and so forth until 100. Okay, or up to 100. Let's get the sum of these 100 numbers. So sum of 1 up to 100. So therefore it's 1 plus 2 plus 3 and so on up to 100. So to get that sum, we know that the first term is this, or the first term is 1, and the last term or the nth term, which is also equal to a sub 100, because this is in this 100 term or 100 position. Now let's consider this example first using the formula of the sum of the arithmetic series. So we know that we were going to get the sum of the first 100 numbers. So that would be S1 sub 100 is equal to, before we do that, let's have the given first. Let's define what are the given from the given examples, or from the given sequence or series. So our n there is 100 because there are 100 elements, okay, in the given sequence, and our first term is 1, and our last term or the nth term is, we have 100. Okay, so that's 100. All right, so we know, class, this is an example of the finite sequence. We say finite because there is the last term defined in the given, so there is a limit. Okay, there's a limit number of sequence. So let's go to the formula. So we know that our n is 100. We divide it by 2 times the quantity of the first term and the nth term. Okay, so we already have the first term using the given. So sum of 100 term is equal to, we have 50 divided by 100 divided by 2 is 50. Our first term is 1, and then plus 100, which is our n term. Okay, so we have it here 50. You work on the parentheses first. So this is 100 plus 1 is 101. So therefore we have 50 times 101. To make it sure, let's try to get our digital calculator. Okay, so therefore we have 5050 is the sum of the 100 numbers, 1 up to 100 numbers. So this is now our answer. Okay. Okay, remember, this example is an example of a finite set or sequence. Now let us proceed to the next example. I may give you the second example, which is to find the sum of the first 20 terms in the sequence 45, 60, 75, and 90. So remember, we just get the sum. Now let's take a look at the given sequence. Okay, so this sequence, there is a dot at the end, so therefore we defined it as the infinite or the infinite sequence, because only four terms is being defined. Okay, so we have the first, the second, and the term, and the fourth, up to fourth term. Okay, so let's get the sum of the first 20 terms. So how do we get the sum of the first 20 terms, where in fact we do not have a given n, or the 20th term? Okay, so we will have the given, which is n. So we know that if there is the first 20 terms, there are also 20 elements in that sequence. Okay, and then the first term here is in the given, of course, 45. Okay, and we have the an, or the nth term, so which is equal to this. Okay, which is equal to the number of terms, which is the 20. So therefore that is a sub 20. Okay, let me erase that one. Okay, so that's a sub 20. Okay, sorry for that. So that's a 20, or the number in the 20th position. So since we do not have yet the 20th position, it's unknown yet because it's infinite. We didn't define it yet. So we need to get first the 20th terms before we can get the sum of the first 20 terms, because we cannot complete the variable in the given formula. So we already have the n, we have the first term, but we do not have the n term, or the 20th term. We do not have a number or the value of the 20th term. So that is why we need to get the 20th term first. Okay, so to get that, to get that 20th term, of course, we need to go back to the formula or general term of the arithmetic sequence. Okay, and how to get the nth term of the arithmetic sequence using the general term or the general formula, which is a20, or the a n is equal to the first term. So we have the first term 45 plus, okay, plus quantity of n. We have n as a given, which is 20, minus 1, which is constant, times d. Okay, so how do we get d? We need to get d. Okay, again, we recall from the previous video that in getting the d, we need to subtract the second term first to the first term. We need to get the common difference. Okay, so to get the common difference, let me use the digital calculator to make sure. Just to show you how to do that. Okay, so we have it 60 plus we have 15. 60 minus 45 is 15, so our common difference is 15. So we can test that one if we also subtract 75 minus 60, the third term, to the previous term, and 90 minus 75. So it is consistent, it is common. So 15 is the common difference, so therefore we already have here 15. So to get the 20th term, we need to work on the operations. So do the parentheses first. So we have it here, the 20 minus 1. Okay, so we have 19 times 15, which is the D. Okay, so we have 285 plus 45. Okay, so the answer is 330. Okay, so we have our 20th term is 330. Okay, make it sure. Okay, so now we already have our given are already complete. We have the end, the first term, and the 20th term. So we may now get the sum of the first 20 terms. So let's substitute all the given variables in our formula. So we have 20 as our n divided by 2. So we have the first term is 45 plus the 20th term. The value of the 20th term is 330. Okay, so let's do the operation. So you have 20 divided by 2 is 10. And then we have times the sum of 45 and 330. So we have it 45 plus 330, that is 375. So we have 375, and then you multiply it by 10, of course. How to do the product with 0? So you just add 0. So we have it 3,750. So therefore, so we have 3,750. So therefore, the sum of the first 20 terms in the given sequence is 3,750. So this is now our answer. All right. And that ends our presentation or our video. Okay. Thank you so much. Let me clean this up first. Okay. Clean that up. Okay. Thank you so much. So I may give you another example. So you may refer it to your study guide. Okay. See you in the next video, or see you in the next video discussion. Thank you so much.